Hi there. Hi there. I have had a lot of parents asking me about how to support their child at home with math. And so I wanted to introduce you to one of my favorite tools, which is a deck of cards. And because pretty much everything that your kids need as far as basic fact skills can be learned through cards. And it's a really great way to be interactive with your child as well. So the first thing I'm going to do is I'm going to take a deck of cards and I'm going to take out everything except all the face cards. I'm going to leave in the tens for right now, but I would take the tens out later as well. So for basic facts, so we're just talking either addition, subtraction, multiplication, or division, although less so for division, because division takes a bit more work to figure out the correct answers. But for instance, for multiplication, you put out two cards. 3 times 10 is 30. 10 times 10 is 100. 10 times 4, I didn't shuffle very well, obviously. 10 times 4 is 40. 7 times 9 is 63. 9 times 2 is 18, and so on. Now, you can play this individually, just as a drill. Go as fast as you can. If the child is struggling with multiplication, then the nicest way to start is by paring the deck down to the smaller cards. So maybe we take out the 2s. I'll just do a few of them. Maybe up to the 5s. So let's pretend that I have a whole deck made of 1s to 5s. And then we do the same thing exactly, but with smaller numbers. So it would be 3 times 2 is 6. 2 times 5 is 10. And so on. Once they get this set figured out and they're confident and they're 95% right, then we can add in maybe 1 or 2 more cards. So we would add in the 6s and the 7s. And then once they get those down, then we would add in the 8s and so on until they're up to all of the cards. You can even use the face cards, particularly the jokers and the queens, to represent the 11s and 12s if you want to go up to a 12 times table. So that's the first thing that I would do with cards, is just basic multiplication. The other thing you can do is you can play war with the exact same set of cards. So we take the deck, we divide it in half. Because I didn't shuffle, this half has all the tens, but let's pretend that's not the case. And then we would each put out 2 cards. Oh, look at me. I got 100, so I'm going to win this one. And this person over here has 72. And we help each other, and the person with the highest number wins and gets to take all those cards. And just like regular war, if it's a tie, so there's 30. Let's pretend this is 30. It's not going to be. Pretend that's 30 also. Then we would each put out 3 more cards. And the card that's the biggest at the end wins. So this guy actually would get to win that round. So that's how we play multiplication war. And we would leave the 10s in. For everything else that I would do, I would take the 10s out, because they kind of mess things up and make it just less fluid. So then I'm going to show you how I would do long division. Now, I'm going to walk through long division step by step. I'll do 2 examples in case you aren't familiar with how it goes. And also, if your child needs to see it, then you can show this to them as well. So for long division, I'm going to take 3 cards. See, 10s mess everything up. So this number is 923 divided by 7. 923 divided by 7. We're going to use an acronym, and the acronym is DAD makes super bacon. Divide, multiply, subtract, bring down. And for most of the kids, we write this out every single time because most of the kids need it. Not all of them, but most of them. So the first thing we're going to do is, how many times does 7 go into 9? The answer is 1. That's our division. Now we multiply. 1 times 7 is 7. Goes right under the 9. Now we subtract. 9 minus 7 is 2. Now we bring down, and we only bring down the 2. So then we say, how many times does 7 go into 22? The answer is going to be 3. Then we're multiplying. 3 times 7 is 21. We subtract. 22 minus 21 is 1. Now we bring down. And the answer is 13 now. How many times divided does 7 go into 13? 7 goes into 13 once. 1 times 7, we're multiplying, is 7. Subtract is 6. There's nothing left to bring down, so this is remainder 6. And that's why I like cards, because you generate a completely random question every single time. And if you're really good at math, you can tell from looking that the answer is going to be have a remainder or not, but the kids won't know. And so it's a really good way to make sure they're practicing their full long division. So one more example of that, we put out 3 cards. See, a 10 messes things up. I should have taken the 10s out. 477. 477 divided by 9. 9 goes into 4. 0 times 9 goes into 47. 9, 18, 27, 36, 45, 5 times. Now we're Dad makes super bacon. So now we are multiplying. 5 times 9 is 45. We're subtracting. 47 minus 45 is 2. We're bringing down. We only have 1 to bring down, and that's 27. And 9 goes into 27 3 times. So 3 times 9 is 27. We subtract. We've got 0. When we've got 0 here and nothing left to bring down, then there is remainder nothing, which we don't have to write down, or it's perfectly acceptable to write remainder 0. So there's 2 examples of long division for you. For 2-digit by 2-digit multiplication, we use a different acronym, and this one is many zoos, many animals. Multiplication, 0, multiplication, addition. So we're doing a 2-digit. Whoops, I got the wrong deck. First one is going to be 98 times 14. So we start with multiplying with the 4. 4 times 8 is 32. We carry the 3. 4 times 9 is 36, plus 3 is 39. Now it's the 0's turn. Put the 0 in the 1's place value. Now it's multiplying. And that 0, kids will say, why do we put a 0 there? That 0 represents the fact that this is not 1, this is 10. So that's why we put a 0. So now we're multiplying again. So 1 times 8 is 18. And then 1 times 9 is 9. And then we get to the last part, which is addition. 2 plus 0 is 2. 9 plus 8 is 17. Carry the 1. 3 plus 9 is 12. Plus 1 is 13. 1,372. So that's how we practice 2-digit by 2-digit multiplication. And another thing we do with cards is we do 3-digit plus 3-digit addition. So that would be, in this case, 835 plus 954. Now we need to add up to the millions for grade 4. But for practice, 3 digits is enough. But if you wanted to extend that to 5 digits, that would be perfectly good. And they will start doing that in class. But the reality is if you can do 3 digits, it's the same process for 4 digits. It's the same process for 5. It just takes a little longer. So, and then we're just adding. 5 plus 4 is 9. 3 plus 5 is 8. 8 plus 7 is 17. 8 plus 9 is 17. Sorry about that. So that's that one. Now, if they're struggling with regrouping, then we need to make sure when we put the cards out, we put them in a way that regrouping will happen. So 666, not much choice there. And 681. So there's some good regrouping ones here. So I might switch this around so that I get 2 regrouping numbers. So I'm going to call this 168 because that's going to force the kids to have to regroup twice. So it's a bit more of a challenging question, even though the answer is going to be smaller. So 6 plus 8 is 14. We carry the 1. 6 plus 6 is 12. Plus 3 is carry the 1. And 6 and 1, and that is 8. 834. And obviously, you can also use cards for subtraction. So it's 3-digit minus 3-digit. You need to make sure the top number is bigger. So when you make your top number, you got to put the big number at the front. But other than that, carry on. The next number probably can just fall out as it will, but might have to get reorganized as well. And again, you can structure it so that it forces a regrouping, but that'll happen. If your kids practice enough, it'll happen. So here we're already borrowing. So we're borrowing, knock, knock, give me 1. Thank you. That becomes 11. 11 minus 2 is 9. 6 minus 5 is 1. 8 minus 3 is 5. So that is the way I use cards in class to practice all the different operations. Also want to just show you really quickly how we can use it to practice fractions. So I'm just going to grab a couple cards. So for fractions, what we're worried about is being able to interpret a fraction, draw the fraction, understand what it means, and also eventually be able to and figure out equivalent fractions. So for instance, this number is 8 over 3. Okay? 8 over 3 is an improper fraction. The kids have learned that. What they know is that this top is the numerator, bottom is the denominator, and that this is the number of parts in the pieces. This is the number of parts we have. So we have 8 parts. We have 3 in each piece. So clearly we need more than one of these. So we draw these until we have enough to fill. So 1, 2, 3, 4, 5, 6, 7, 8. So when I'm representing this, this is going to be represented by 2 wholes and 2/3. So that really helps kids to simplify this fraction down to 2 and 2/3. So that's a way we can use fractions, and a way we can still use cards, and we can make it all one 10-minute session where they do some of all of these activities. If they don't understand fractions, drawing them out is the best way to start. And equivalent fractions are hard to do with cards, but we certainly will do them in class lots of times for them to practice. I hope that helps, and if you have any more questions, please let me know. Thank you.